In the early days, databases kept track of new data using a simple ticket dispenser. Just like at a local daily counter, every time a new user signed up, they got a number. User 1, user 2, user 3. It was beautiful, it was fast, it worked perfectly until your business actually succeeded. Suddenly, you aren't running one local daily anymore. You are running 500 of them across the globe simultaneously. Millions of users are hitting your servers at the exact same millisecond. If a server in London and a server in Tokyo both hand out ticket number 1001 at the exact same moment, the entire system crashes. To prevent this, the servers have to constantly call a central authority to ask who gets the next number. That constant checking creates a massive digital traffic jam. But it gets worse. If your profile URL ends in user 1001, a competitor knows exactly how many users you have. They can just change the number in the browser bar to 1002 or 1003 and scrape every piece of data you own. So, the tech industry came up with what seemed like the ultimate savior, a completely randomized 36 character string called a UUID 4. There are more possible combinations here than there are atoms on Earth. Two servers can generate an ID at the exact same moment with zero chance of ever colliding. No central authority needed. Perfect security. Every major tech company switched to it. It became the gold standard. But it was a hidden trap, and it took years for the industry to realize the catastrophic price they were paying for it. To understand why, imagine a meticulous filing clerk who keeps a giant cabinet perfectly alphabetized. When you use the old ticket dispenser method, it is like handing the clerk a file that goes neatly at the very back of the last drawer. It takes a fraction of a second. The clerk barely moves. But using the random method is like a chaotic boss walking into the office and dumping random files on the clerk's desk. The first file starts with M, the next with A, the next with Z. A clerk has to open a random drawer, pull hundreds of folders out, cram the new folder into the middle, and shuffle everything else down just to make room. In a database, this exact nightmare is called a page split. Databases store your data physically on a hard drive in structure blocks called pages. When you force a completely random string into a page that is already full, the database has to freeze. It splits the page in half, moves a massive chunk of data around, and rewrites its internal map. During year 1 of your startup, traffic is low. The drawers are mostly empty. Everything feels lightning fast. But by year 3, your database is spending 80% of its energy just shuffling papers around on the disk instead of serving your users. Your drive fragments, your cache becomes useless, your hardware runs hot, and your cloud provider sends you a massive bill for the extra computing power. For a long time, engineers thought this was just the tax you had to pay for running a massive global system. There was simply no other way until recently. The global body that governs internet standards officially stepped in to kill this problem forever. They updated the rules to introduce a new weapon called UUID7. The genius of it is incredibly simple. It takes that massive, unique random string and splits it down the middle. It dedicates the very first section exclusively to a timestamp measured in milliseconds. The remaining section is filled with pure randomness. Look at what this changes because the timestamp sits at the very beginning of the ID. Every single new record generated is naturally larger than the one made a millisecond before it. The IDs are chronologically ordered. Back in our filing cabinet, the chaotic boss is finally gone. Every file handed to the clerk now goes neatly into the very back of the drawer because it is sorted by time. Page splits drop to absolute zero. We actually ran a live showdown to see the raw data. When you index 1 million rows using the old random method, the insertion speed slows down exponentially the larger the database gets, leaving behind a massive fragmented mess on the disk. But when you run the exact same test with this new time sorted method, the speed matches the old school ticket dispenser perfectly. It stays a completely flat, lightning fast line, and the data on the disk remains incredibly compact. You get all the security and freedom of a globally unique identifier with absolutely zero performance penalty. The industry is shifting rapidly. If you are still building systems using random strings for your primary keys, you are actively writing a tech debt check that your company will have to cash later. Swapping to a time sorted identifier is the easiest code change you can make this year to save your infrastructure, your budget, and your sleep.